Hello, I have returned. Why have I returned? Because I don't like to give up. I am so close to getting this thing fixed after so long. Having this in and out of the bench here, or in my case the table, I just had to do something. I could not let it go. So what you see here before you, besides the ill monstrosity there that I'm going to fix, we have the breadboard of wonders right there. So what I've done is I have created, sorry for that, the 555 timer circuit that's on the Amiga 600 motherboard, breadboard style. If I would stop hitting things with this piece of paper, anyway. So I'm going to zoom in on this a bit. So the LED you see there, the red one that's not lit up at the moment, is currently off because I have not applied any power. Now, the way this works seems counterintuitive depending how you look at it. The LED itself, when it's off, the Amiga, let's say this on the Amiga 600 motherboard, will be in reset mode, okay? When it's on, it will turn off the reset signal, and of course the computer will be allowed to boot. So I'm going to push this switch here, and there's going to be a momentary delay, about a half a second, maybe a second, and then the light will come on. So I'm going to push it right now, and you see the light has come on. Okay, so you'll hear the click, but then there'll be a slight delay. That's the reset signal. Now, one interesting thing that we're going to look into is I was following this schematic religiously, especially when it's in its zoomed in state. But one thing I just realized when I had to troubleshoot the breadboard because it wasn't working, and I realized, well, where's pin 1 and 8? Well, pin 1 and 8 is one's ground, 2 is power. It's not even listed on here. So this thing wasn't getting any power, and it wasn't working, obviously. The LED was doing nothing. So I think what's happening now is with that, remember I said for some stupid reason, desperation, I went through the 4th timer IC, sorry, 555 timer on the motherboard here, which somewhat, you know, I've replaced that several times, way more than I should have. And after troubleshooting, you know, the breadboard, and I realized it didn't have power, this thing's behaving the exact same way the breadboard did until I hooked up, you know, pins 1 and 8 to, you know, ground and power. So with this timer IC, is it getting power? I never really bothered to check. I was checking everything else on the sheet here, you know, which is of course horribly zoomed in at the moment. Checking out all the voltages where it says VCC and, you know, transistors switching. Was that working? Was the base, you know, of these things getting the power, whatever. It never dawned on me to check, is there any voltage getting to the integrated circuit, the 555 timer? So I'm going to check to see, is there any voltage getting to that thing? Because when I didn't have the, I know I'm kind of rambling here, but I need to explain this a bit. When I didn't have the power hooked up to this, and of course the LED wasn't doing anything, on pin 3, which is the output, which like I said previously before, that's ground, and it will be grounded once this timing cycle is completed. When this LED comes on, pin 3 goes low, this turns on. So low equals on for this LED. Well, before I hooked up power to this IC, because I didn't, you know, I was following the schematic, I didn't have pins 1 and 8, I'm getting 0.7 volts, 0.7 to 0.8, which is enough to trigger the transistor to keep the LED off. So that might be our problem. So what I'm going to do is I'm going to see if we have power up there on the board. This is what's nice when you put stuff on the breadboard. I discovered by accident that because I didn't hook up the power, it wasn't working. It was doing the same thing the motherboard was doing, even because remember the voltages from before, doing the exact same thing. So the beauty of the breadboard is you can do all you want. You can muck around with all the wires. I know it looks hideous, but it functions, and everything else. And I particularly ordered, can't see it in this mess of wires, but it's particularly ordered the, you know, breadboard friendly version of the 555 timer just for this purpose, to troubleshoot the circuitry and help me understand more of what's going on. Anyway, enough of that. I'm going to get all this stuff out of the way, and we're going to see if we have any voltage going to the, I guess it would be pin 8 of the 555 timer. And we, or I, or someone, will be right back. Well, my hopes have been dashed once again. So as you can see on my highly reflective HP monitor, the black screen has returned. Well, it hasn't returned, it has persisted. So yes, the 555 timer had ground and 4.8 volts, 4.9, which is what the power supply kicks out, which is close enough to 5. So that, unfortunately, is not the problem. I probably checked this eons ago and forgot. And so that was a red herring of sorts. But there might be something else that's going on here that might be the issue. Now I'm going to hold my breath on this, but we'll see through the course of this video if it's correct or not. So as they say, back to the drawing board. So the beauty of building that breadboard circuit you saw earlier, it proved the dysfunctions. Of course, I know it did because it worked on this computer and for decades until just recently. But it gives you the option of testing points and adding removing parts much easier than, of course, doing it on the motherboard with SMD components and all the soldery goodness. Yes. So what I did is on the breadboard circuit, this is your trigger right here. Okay, so the trigger going through this resistor capacitor network. So according to the data sheet, on the trigger input, if the trigger is below 1/3 supply voltage, which in this case 5 volts, it's about 1.7 volts. So 1.7 volts or lower, the output, which is here, will be high, which means it turns on this transistor, which passes the circuit here to ground, and it basically is your keyboard reset. It holds the Amiga in reset mode. So what's happening here is this voltage on the breadboard circuit, it's around 5 volts, right here. On this motherboard, it's at under 0.1 volts. So it's constantly being held low. That's why this thing is in perpetual reset, continuous reset, if I want to say that, I guess, which I just did. But anyway, so what I did on this motherboard here is trying to get, let me take that off there. There we go. Okay. Is I removed this transistor. Sorry, it's a bit off angle here, right here. So this is the keyboard reset, as in your 3-finger salute, the control Amiga. If all 3 inputs are high, it will trigger the output to high, turns this transistor on, conducts to ground, which of course will be, through this 1 mega ohm resistor, will bring this below, very close to ground, which in my case is like under 0.1 volts. And, so it's keeping this circuit constantly grounded. So what I did is I removed this transistor. So this takes this out of the equation completely. So just act like this is not here, okay? So all that's in the system is this resistor and this 0.1 microfarad capacitor. Well, when I measured it on the Amiga 600 motherboard, so remember, this is not here anymore. So the only thing that's actually the trigger is seeing is these components. It's still at 0.1 volts. So I know that there's nothing wrong with this transistor, and there's nothing wrong with the logic circuit that's controlling the control Amiga keyboard reset. So this tests fine. It's 1 mega ohms. And this is the problem. This capacitor reads very low on both sides. So the way this is going to work, On the ground side, of course, you hook the multimeter up, you're going to see ground, right? Now, even though this is a 1 mega ohm resistor, this is very high input impedance, obviously, to this, you should get almost 5 volts on this side. And I do on the printed circuit board, I get 5 volts. I still get 0.1. So I think there's something not right with this capacitor. So we're going to visit the motherboard, and I'll show you the test I did. And I guess what we'll do is we'll remove that capacitor, see what happens. Okay, as you can see, I have the Amiga 600. It's on the bench, powered up, the black screen of death prominently staring at me. Multimeter on hand. I have the ground of the multimeter, this cable here, hooked up to the ground of the computer, and of course my positive lead to do the positive poking. And hopefully we'll get positive results. Yes. Anyway, so just to prove to you, this is the 5 volts in to the 555 timer, and as you can see, it's fine. And of course, ground will be close to 0, which is on this side, which is this is pin 1, and that is pin 8. So pin 1 ground, pin 8 positive 5 volts. So there, the eureka moment I thought that I had earlier was not very urethra. It wasn't very positive. What am I even saying? I don't know. Let us continue, shall we? So what I'm going to do here is, this is that capacitor that's hooked up to the 1 mega ohm resistor. So basically positive through this to ground. And ground is on this side of the cap, as you can see, because we're very close to 0 volts. On the breadboard, I got around 4.7, 4.8 volts here. And what do we get on this one? Not even close. So 0.3 volts. So because this is well below the 1.7 volt threshold, like 1/3 of VCC, which of course is 5 volts on these computers, it's going to keep the output high. And the output is number 3, which is right here. So if I probe this one, it's 4.8 volts. Sorry. It's hard to get these on here. Sorry. It's 3.4 volts, which is definitely high. Most transistors will trigger at about 0.7 volts. So that's way above, and because that transistor triggers, it conducts to ground, which pulls the reset circuit to ground, which basically resets the Amiga, but because it's constantly below the threshold of 1.7 volts, it's completely in, continuous reset. And like I said, this circuit is, this chip here is responsible for the 3-finger salute, the control Amiga key combinations. And like I said, if all 3 are pressed, this will output a signal. This is disconnected. The transistor that would do the switching right here has been removed. So that circuit, like I said before, is isolated. So I'm going to take out this capacitor, and I've done this before, but I'll show you. We'll get our voltage back here. So I think there's something wrong with this. So right now, just to show you one more time, we are at 0.03 volts. So let me remove that, and we'll test that point again. Okay, I have removed, sorry for all that clacking noise, I have limited room, like I always say. So the capacitor was here. So same as before, power is not on. One moment. Power is now on. That would help. Okay, so the ground side of where the capacitor was is here. If you look at the meter, we get close to 0 volts. Now remember, we're getting 0.03 or something to that effect on the junction between the 1 mega ohm resistor. Remember, this is on input 2 here. Breadboard, we had 4.7 volts, and then before we had, there we are, 4.3 volts. Before we had, remember, 0.03. So because of that, because it's removed, the computer is now out of reset. Let me tilt this up. You're going to get a bit of glare off my fine monitor. Let me zoom out here. There we go. You get to see the miscellaneous artifacts in my kitchen. And we should get the eventual kickstart screen. There we go. So by removing that capacitor, of course, now it's it will boot, of course. But of course, I keep saying of course. Yes, but let's continue. So the thing is, I need to put the transistor back in again for that circuit, so my keyboard reset will work. Because right now it would be the same as before. If I remove that one baud wire I put in there because of the trace that was lifted, you can get it to boot, but I can't reset it via the keyboard. And right now that won't work because one, the capacitor is out of the circuit. It may or may not work without that, but the main thing is the transistor is not in place, so the keyboard reset will not work. Anyways, I tend to ramble a bit, but I'll stop, I promise. So what I'm going to do is I'm going to throw that transistor back in there and then see what happens. And if everything looks good, I will add another capacitor. Now I don't have that's a 0.1 microfarad cap. I'm going to have to steal one off my donor board of an old Amiga 1200 board that got slightly fried on the video port. So I've been using that for parts. So I found a part on that board I can take off. And yeah, and then we'll go from there. So I'm going to throw that transistor in circuit, which I'll zoom in for you for a bit, if I can know what the word zoom in means. There we go. Yeah, let me try to lock this down for you. Yeah, you can see the transistor. Right, maybe I should use some kind of non-conductive components here. Yes. So the transistor right there, those three pads, that's a transistor for this keyboard reset. So like I said, the keyboard reset, once it's done, turns on this transistor, which goes to the 555 timer and pulls it to ground, and you reset. So there we go. So I'll put that transistor back in there again, see if it still behaves, at least boots, and then put in a different cap, one from the donor board, 1200. Yes. Anyway, I will be right back. Okay, after some messing about, because it's always fun soldering some very small surface mount parts, including this transistor right here. So it's in place. Remember, this is necessary for this logic tip to yes, a logic tip. Always put your zeros before ones. Whatever. What we can do here is try to get back on track. Sorry, today's just not one of my days. I haven't done a video for a while. But this is the logic chip that triggers that transistor, which sends the keyboard reset to the 555 timer. But the good thing is, except for the capacitor at the moment, the computer boots. So I'm going to put the capacitor that I stole from the Amiga 1200 donor board, and it is very small, very itty bitty tiny thing. Not sure if I can get this down here or not. That thing, if it's going to focus on my hand or not, right there is the surface mount capacitor, 0.1 microfarad. And just to let you know, that transistor is the same size, and it had 3 legs versus 2. So I will install this, see if it still boots, if I don't lose it. I gotta be careful with these things. They disappear into the 5th dimension in no time. So keep a big supply of them just in case. But anyway, we shall install the capacitor and see if we still get our boot screen. I shall be right back. Okay, so here it is, it's showtime. So I have everything but the keyboard connected. The reason why is if this still doesn't work for some reason. I don't need to connect the keyboard because it's kind of pointless. The keyboard is in an existing Amiga 600, which I don't want to disassemble unless I absolutely have to. Anyway, I have the capacitor, the transistor, all of that's back the way it was. Hopefully this will work. So I'm going to power it on. As you can see, I have the compact flash and the floppy drive over there. So this thing should boot, if it's going to, relatively quickly. So let's see what happens, shall we? And I'm a bit worried here, but we shall see. And I will creep around to the other side here and turn on the power. Let's see what happens. Fingers crossed. It's booting. What do you know? So that's good. The ultimate test is going to be when I hook up the keyboard, if I can reset it with the keyboard using the 3-finger salute, the Control Amiga. So, and of course I had to choose a compact flash card that doesn't well, there we go. It was just slow to boot. Sorry, I was impatient. Yeah, there's no fast RAM on this, thus the slowness. And the incorrect time, because there's no real-time clock on this. Excellent. So this is progress, but the ultimate solution is when I hook up the keyboard. Solution? No. The ultimate proof is when I hook up the keyboard, can I reboot it? So I'm going to go grab the keyboard out of a unsuspecting Amiga 600. I'm only borrowing it. I'm sure I'll tell it that first so it doesn't feel offended. And hook it up, see what happens. I shall be right back. Okay, as you see before you, I have installed the Amiga 600 keyboard, the donor Amiga 600 keyboard, which will be returned to its rightful owner soon. The keyboard does function, caps lock light. I tried the keys, they all seem to work. So now the moment of truth. Control Amiga, or the AKA the 3-finger salute. Will it reboot this computer? And we shall see, shall we? Just a bit of zooming in. Here we go. So, Control Amiga, and here it goes, the last one. Look at that. Amazing. It is fixed. Finally fixed. At last, I have a revived an Amiga 600 from the ashes. Like I said, there could have been a workaround for it. There's ways you could have got it to work. You just would have to install a reset switch or just power cycle it if it, crashed or you needed to reboot because of games or whatever. But, it's nice having everything working the way it's supposed to. So, as you can see, as I keep saying that, let me zoom in here to that wrong part of the circuit. There we go, the circuit of interest. So just to keep in mind, as I attempt to adjust this camera, this board was recapped, and I didn't recap it because of this keyboard reset or permanent reset problem I was having. There were some leaky caps, there was some that were starting to fail, or at least looked like they were going to fail. Now normally, if you watch Jan Beta's channel or a few other people, this capacitor here is normally to blame. It's fine. I think it was fine before. I replaced it. I replaced it again. I replaced this poor timer circuit, the 555 timer, 4 times. This is the 4th iteration, and I don't know why. You stick your hand in the fire once. I'm pretty sure if you do it another 2 or 3 times, it's going to do this. You're going to have the same results. I guess I thought that maybe there's heat damage, too much dwell time on the soldering iron, but that wasn't the case. And I even replaced the keyboard reset logic chip here. This is the one that senses the Control Amiga keys and then passes it on to the timer. Anyway, but I never thought this capacitor here, right beside it, which is a 0.1 microfarad, would be wrong until I did that voltage test. And like I said before, I was thankful I built the breadboard version because it was easier to figure out how it's supposed to operate out of circuit, obviously, because it was standalone, and then it kind of had me hone into that area. And like I said, what was weird is that cap tested fine, on this blurry meter. Sorry, and everything was, but apparently once it's in circuit and it has voltage differential placed across it, it fails. So the donor capacitor from the 1200 scrap board that I have works just fine. So that brings an end to this video and this very long saga of this repair. So just keep in mind, if you have a reset issue like I do, it may not just be that one electrolytic, it might be that 0.1 microfarad capacitor that's causing all of your headaches. So I'm not sure if it failed because it was close to the other one, even though I said the other one didn't seem that bad for leakage. And it tested fine, that capacitor tested fine, but still it fails in circuit. So there you go. Sometimes you just have to figure things out. And one thing to take away from this video is no matter how much adversity you have, how much of a challenge, if you are persistent, you will overcome. And if you don't, at least you know you tried. You gave it your all. Yes, finally, this repair has ended, and it has ended with success. Not all of them do, but give it your best and you'll never know what you'll be able to be capable of. And just a reminder, if you have not subscribed to this channel, please do. If you like the video, give a thumbs up. If you did not for some reason, you know what to do. And I will see you next time. Thanks for watching.